economist at the World Bank and the climate change group of the World Bank, of which he's a member since 2012, after being quite a while in academia. And so Stéphane's research focuses on the economics of natural disasters, also climate change, adaptation and mitigation, and green growth. And well, he's made quite some important contributions to this field, and looking at different types of natural disasters, going from floods to climate extremes, sea level rise, and recently also of the studying the economic effects of the COVID-19 pandemic. Stéphane has also been one of the lead authors of the 5th assessment report of the IPCC. And what I find very interesting is that Stéphane is not just an economist, but actually he also holds degrees in engineering. I think a master's degree in meteorology and climatology, and then he did his PhD in economics. So quite interdisciplinary background. And so I'm very curious about your thoughts on modeling the impact of natural disasters on poverty. And so I would just hand over to you and ask you for your presentation.
Thanks very much, and thanks for the invitation. So as Anton said, I'll talk about the impact of natural disasters and try to look at this issue from the perspective of our job at the World Bank. So I'll go through a few of the rationales for this work, and also the type of modeling that we're trying to do. And as you will see, everything is kind of like work in progress, and everything is kind of like shortcuts because it's difficult to model the real thing and so on. So on all of those issues, we're always very interested in collaboration and exchange and working with others. So as I present, please keep in mind that any ideas, any feedback, any proposal for collaboration and so on would be very, very welcome. So let me maybe start. I hope you see the right screen with the full slide. Yeah. So let me start with a little bit of why we started this work on natural disasters the way we did. Imagine you manage like a fund to finance disaster risk reduction, and you're given like 2 projects, and you can finance only one. If you follow the rules and the process that we have, what we're doing is we're doing cost-benefit analysis, and you look at the costs and you look at the benefits of your project. And in a case like that, 2 projects with the same costs, one gets 20 million in avoided losses, the other one 5 million. According to our rules, we just finance project A. And basically the fact that maybe project A protects a very fancy neighborhood with fancy cars, and project B protects a slum with maybe tens of thousands of people. Of course, the avoided losses will be lower in the poor neighborhood because people don't have much to lose. But still, if you do a cost-benefit analysis, it's clearly the project A that's the best one. And our mandate is to reduce poverty. So of course, we're not completely happy with that methodology, and we were starting to work on how to assess projects in a way that takes into account not only how much benefits you have, but also who benefits and what it really does for people's lives. So we did that by starting with a classical risk assessment. So you look at the hazard, which is a physical event, exposure, the population and the asset affected, and the vulnerability. And this is the typical thing that we use to calculate asset losses, which is what you see in the newspapers after big disasters, but don't really tell you anything about what people experience and what it does to families and to people and their life and their well-being. So what we're trying to do is to add one block to this framework that we call resilience. And that is something that tries to link asset losses. So your roof has been damaged, your house has been damaged, your factory has been damaged, to your well-being. And we define resilience as the ratio of those losses, which means that if resilience is infinite, you can experience as much asset loss as possible. So you can lose everything you own and so on, but your well-being is not affected. You're infinitely resilient. If resilience is zero, if you lose like $1 of your assets, your well-being goes to zero. So it's really a measure of the ability to experience material losses without experiencing well-being loss. And of course, it depends on households and families and what people and families own and how they derive an income. And it also depends, and I won't go into the detail of this figure, but it depends of all of the tools that people have to manage shocks. So if you're this family and you're losing the little house in the back plus some of the goats, what do you have to manage that? Do you have your revenue being diversified so it's okay because you have another income? Do you have savings somewhere? Can you borrow? Maybe you're insured, or maybe you have like a social protection system that will come and help you. So it really depends on the condition of the household, and that's why we do the modeling at the level of the household. So how do we do that? So in each country, we have household surveys. So typically in the Philippines, we have a survey of 40,000 households, and we have their demographics. So how many adults, how many elderly, how many children, and for every individual, like the education level. We have the weight of the household, which is how much each of those households represent in the population. And we have information like we have income and income sources. We have exposure because we have localization of the households, not perfect, but we have some idea. So we know the likelihood that those households will be affected by a shock. We know the type of house they live in, the type of roads that they have, and so on. So we can assess the vulnerability of their assets, and we know how they are protected by social protection, insurance, or things like that. And based on that, so this is an example in the Philippines, in one region of the Philippines. This is a distribution of consumption in one region. So most people are having about 20,000 pesos per year and per person. And the big bar on the right is all of the people richer than what fits on this figure. So then what we're doing is for each household, so we model it like 40,000 times in the Philippines, we do the normal risk assessment. So we look at the different hazards like floods and earthquakes. We look at where people are, and we look at the type of housing and assets and income source they have, and whether they have early warning systems and so on. And we try to assess how much they're losing if there is a disaster. Not at the regional level, but really at the household level. And very important, you have like this K, which is the amount of assets people have. And part of that is the assets they own, like their house or their goods. Part of the assets that matters for households is also assets they don't own. So if you work in a factory, if the factory is damaged, you're affected, even though you don't own the factory. Somebody else is owning it. But if you want to understand what happens to a household, you cannot look only at the asset they own. You have also to look at the asset somebody else owns that they use to make a living. And of course, there are like all of the public assets that will help the system function. So like the roads. So it's very, very complicated because you cannot just look at one household individually because their income will depend on the assets of others. So the way we do that is we don't look at the assets people own. What we do is we look at their income, and we estimate the assets that they use to make that income based on that income. So we don't really care who owns what assets. We change completely in terms of representation of the assets, and we allocate assets not to the households who own them, but the assets that people use. So we can estimate how much private asset people will lose, how much of the asset they don't own but they use that they will lose, and the public assets with like characteristics of those assets. So we know that in the Philippines, a certain fraction of houses will be very robust modern ones, and we know that there is a fraction that will be like huts or like shacks in informal settlements, and we try to just do that assessment. And based on that, we can estimate the impact on assets, so which is the classical thing, so the value of the damages. Then the question is to add one step to look at how those losses in assets transform into losses in income. And that's, again, full of complexity, where to do that well, we would need a full representation of the economic system, and we can't do that because we don't have the data and we don't have the capacity to do it. So how does it work? So I don't know how much economics you have seen in your work, but to represent income, economists tend to use super simple functions, right? On the x-axis here, you have the amount of capital you have, and on the y-axis, you have how much production, which means income, you get. And the idea is the first unit of capital brings you a lot of income, and then as you accumulate capital, income, kind of like the returns are declining as you accumulate capital. And the idea really is, imagine you have only cars as assets. The first cars you have, you will use as ambulances, and they will be super useful. Then the next one you will use as taxis, and they will still be super useful. And as you accumulate cars, the last ones will be used maybe 5 minutes a day and are not very useful. So if you lose some cars, if you use the classical economic modeling that people are doing, your stock will move to the left and your income will decline. And of course, there is just a tiny little problem with that, is that it assumes that the cars, if I keep my example of the cars that you have been losing are just the last one you have added, right? So the least efficient ones. And this looks silly, but that's the way most people are modeling natural disasters in economics these days. So they just take the stock of assets. They assume the stock of asset is reduced, but because they use models which have never been designed to look at natural disasters and shocks, they're kind of like missing the fact that a natural disaster is sort of a random shocks, and you don't know what type of assets you will be losing. So in our modeling, we're really trying to get back to the physics. This stock of assets is not some sort of like abstract number, but it's constituted of many different things. So with my examples of the cars, in fact, you'll have to represent the fact that your assets are some ambulances, some taxis, and some individual cars. And if you just average everything into one number, which is your number of vehicles, you will be losing the fact that if you lose all of your ambulances, you will be worse off than if you are losing only individual cars. So since you have complexity in your group title, I think this is really the core of the issue we have, which is the stock of assets, which in economic models is represented with one number. In reality, is an infinite number of very different type of assets that interact in a very complicated manner. And we're completely unable to represent that complexity in our models. And we're only using shortcuts, and sometimes those shortcuts create very, very big biases. So just to give you an example, this is the Bay Bridge in San Francisco. And that was after the earthquake in the 80s. This little segment of bridge, if you lose it, it's not any asset that you're losing, right? You're cutting the big connection between two economic poles in your region, and the impact on your economy is completely different from the same type of impact that would have affected any other bridge or any other road in the area. So it means that if you want to really translate loss of assets into loss of income and loss of economic activity, you would have to especially represent the network effect. So in theory, you would want to have all of the supply chains, all of the transportation network and communication network that support the functioning of your economic system. And you would want to take into account the fact that if you're in Belgium or if you're in Madagascar, losing assets has very different implications, because in one case you have a lot of redundancy and you have a very complex system. And in Madagascar, if you lose one road, you're very likely to just disconnect completely one region in the country. And of course, our challenge is when we're working in one country, we can afford to go into that level of details and to do very detailed work. But we're working on all countries in the world, and we have questions coming to us with like a few weeks to answer. So the question is, how can we give an answer which is not too biased, that kind of like take into account the complexity of those systems, if you don't have the time to do the super detailed modeling that kind of represent everything. So we have some tools to do that, and so this is a study that we have been working on for like almost 2 years now. And the idea is to have for all countries a relationship between, in the transport system, how many roads you're losing, and this is your x-axis, and how much you're losing of the system output. And so what you see, that Belgium is in blue and Madagascar is in red. If you lose 10% of the roads in Madagascar, you lose about 75% of your system output. In Belgium, you lose maybe 2 or 3% of your system output, and that's because you have much more redundancy in the Belgium system. So the idea is to have for all countries maybe one number that would help us translate loss of assets to the loss of income. And maybe we can do this work once, and then we have this number somewhere. And if somebody is asking us a question that we have to answer tomorrow about Madagascar, we can just pick that number and use it. And of course, it will be a super simplification. But if you have 1 week to answer a question from a government, we cannot really afford to just do a 2-year study every time we have that question. So that's the kind of things that we have been working on quite a lot, trying to do in some cases super sophisticated modeling, but trying to transform the results into rule of thumbs that then we can use very quickly in other cases. And I think Célian Collomb is not here, but he's part of this group, and I'm sure he has shown the work we did in Tanzania, where we did exactly that, like a modeling of supply chains and the transport system, and we tried to identify for all of the roads what is the value of the road for the economy, so that we could be smarter when we transform like the impact of a disaster into an impact on the economy. So I won't go into the details because I guess you have discussed that with him already, but that's the type of study that we're doing quite a lot of. When we don't have a super detailed study, well, we do like simplifications, but we don't do the same simplifications most of the economic model are doing. Instead of getting back to my example of the ambulances, taxis, and cars, instead of assuming that if you lose vehicles, you will lose only the least useful ones, which is in that figure, assuming that you move from point A to point C, we assume that you lose the same fraction of each type of capital you have. So you lose a fraction of your ambulances, a fraction of your taxis, and a fraction of your individual cars. And it means that the relationship between the assets you have and output is moving from the blue line to the red line. And this is a tiny change in modeling. This is also a very a sort of like heroic simplification of the complexity of the situation. But we feel that doing this approximation instead of the other approximation is closer to the reality of the impact of disasters. And this very tiny little change is basically multiplying by 3 the impact of disasters if you're doing the simulations. So it looks like a detail. It's like in the weeds of the economic representation and so on. At the end of the day, if you multiply your assessment of the risk by 3, the policies you will implement in the country, the disaster risk reduction projects you will implement, everything will be very different. And it all relies on this very big simplification that we have to do to fit disasters in our model. So I think in thinking about like the research frontier, I think being able to do some better, simple representation of the complexity of the impact of disasters for me is a very big priority. So I won't go too much into the details, but there is another thing that we need to represent in our models to really understand disasters. It's the reconstruction phase, because if you represent properly the impact of disasters on outputs, what becomes really important is how long it takes to reconstruct. And again, we did some very rough simplification of this problem, trying to look at, if you have, imagine you're in a country and you lose like $1 billion in assets, how the impact on the total economic cost depends on how long it takes to reconstruct. And this is the figure you see on the right here. Basically, you have like a multiplying factor. If you can rebuild everything immediately, you have 1 economic cost. If it takes you 10 years, you're close to doubling the economic cost of the disaster. So there is a huge value in going back quickly. And I mean, it looks like it's obvious, right? When you have a disaster, the fastest you rebuild, the faster you rebuild, the better off you are. But it's not something that is introduced in a lot of the models that people are using, as even though it might seem surprising. And one of the reasons why it's not in the model is because at the country level, disasters are almost always small. If you take Katrina, the hurricane that almost completely destroyed New Orleans in 2005, if you're using a model of the US, the losses are more or less 2 weeks of investments in the country. So if your model is very aggregated, what the model will do is it will take 2 weeks and rebuild everything. In reality, between the 2 images you see on the screen, there are like more than 10 years to just go from the destruction of New Orleans to something that looks like coming back to normal. And the reason why it takes 10 years and not 2 weeks is because of 3 types of constraints. Financial, so if people don't have money, they cannot rebuild. Technical, you need people who know how to build houses, and there are not so many of them. And institutional, because to rebuild a city like New Orleans, you need, for instance, building permits for all of the houses, and this is not something that you do in 2 weeks. So again, here, my point is, if you ignore the complexity of the reconstruction system process, you arrive at absurd results, like you rebuild New Orleans in 2 weeks. But we don't have good models to represent these 3 constraints: financial, technical, and institutional, so that we can have a good representation of the reconstruction.
So quickly ask a question here, Stéphane.
Yes.
So, because when you're referring to the standard macroeconomic models, what is the benchmark here? Is it CG model, or what are you considering as the standard models for natural disaster analysis?
So people have been using 4 types of models. So you have the CGE. You have people using input-output models, which is more or less the same thing, except that you don't have market responses when prices change, and you don't assume that the markets always balance demand and production. But you have also people using DSGE, so dynamic general equilibrium models, which are a lot like CGEs, but they don't have the sectoral complexity, and instead they represent better the dynamics. And you have a fourth category, which is what we call macrostructural models, which are also models that are used to look mostly at the dynamic of the economy. So they don't have a lot of sectors. They are not very granular, but they try to look at the month per month or quarter per quarter dynamics. And macrostructural model and DSGs are typically used by ministers of finance and central banks to try to design monetary and fiscal policy. But all of those models, all of them, tends to have the same representation of the economic system in terms of how it transforms assets into economic activity and income. Mm-hmm. So we have very different models on the market, quote unquote. People use models depending on their needs and what they are working on. But the issues that all of those models have been designed to look at sort of a long-term economic dynamic, and not at what happens when you have a big shock at one point, randomly taking out some assets, means that they have the same bias, all of them. And also, if you're interested in the long-term evolution of the economy and you assume that you don't have very big shocks, but only like small changes, you don't have to look too much into constraints like I have only, I don't know, 10,000 roofers in my region, and when there is a disaster, I need 10 times as many roofers to do the reconstruction, because demand is changing slowly. So even if you have tensions on labor markets, it will always be like marginal. When you have a disaster, you have in some categories, for some sectors, you have massive scarcity because you don't have enough capacity. And those models, they don't have that because they don't need to for the type of problems that they were designed to deal with. And then now, because we have a lot of political pressure to bring climate change into monetary policy, bring climate change into fiscal policy, and it's good that policymakers and politicians are asking us to do that. But what people do, they take the models they've been using for other things, and they try to just plug this new problem. And because we have a lot of pressure and not a lot of time, they do it in a way that's super simple. And they will tell you, yeah, it's an approximation, but that's fine. But if you're missing the mark by a factor of 3, it's kind of, I mean, in economics, a factor 3 is a small uncertainty, but it's still sort of a problem if you minimize the impact of all disasters and climate impacts by a factor 3. I mean, it makes a difference in your decisions. So this is really across the board, and I really think that this is a really, really interesting topic, because it really requires the intersection of sort of like an engineering view of the economy, and the real like physical flows, what's really going on, how you transport things, very like explicit representation of the functioning of the system, and the economics in the sense like relatively simple models, very aggregated, to just like look at policies and so on. So it's a really interesting interface to be working in. And I think that if we fix that problem for disasters, we might also improve quite a lot economic modeling in general. So it's not only about disasters. Feel free to interrupt. When this is always much more difficult remotely to get a sense of whether you want to stop on some topics and discuss them further or something like this. But very happy to just drive the discussion where you see the most interest. So on this reconstruction, what we're doing in our model is, again, a completely ridiculous simplification. we basically assume that the reconstruction will be a nice exponential for the three types of assets we have. So for the people's house, they will rebuild with the capacity of the household. So if people are really poor, they might take a long time to rebuild. If people are really rich, probably Bill Gates can replace his roof overnight. So here we have a first factor for the speed of the reconstruction. We have another factor for the reconstruction of the factories and other means of production. And this is more linked to the companies and the business sector. And we have the speed at which the public sector can rebuild. So how fast the governments can repair roads, for instance. And for us, it's nice to have those three categories because you have different policies for those different categories. So if you provide social protection to people, you will accelerate the reconstruction of people's houses and their own, like replacing their fridges and stuff like that. If you have a better budget process where your Ministry of Finance will be very quick to reallocate budgets, you can accelerate the reconstruction of public assets. And with our models, we want to be able to represent those different things at that level of granularity. So when we do all of that, and as I said, I mean, I think we're doing it better than others, but this is so far from where we would like to be that there is really a lot of work on this income loss block. Then we transform that into consumption, and here we introduce a whole new set of things like how people have to cut consumption when their income drops. And this is really where the poverty angle gets in, because of course the ability to keep consumption up when your income drops depends on whether you have savings and basically how rich you are. So without getting too much into the details, we transform the income loss that you saw in the previous figure into a consumption loss, and it depends on your savings and stuff. So when we do all of that, remember at the beginning I had my distribution of consumption. For each household, we do all of this modeling, asset losses, income losses, consumption losses. And the end result is that we have this consumption distribution that shifted to the left. And it's not just shifted to the left. Like you cannot just assume that the distribution doesn't change, but everybody is using the same thing. What happens is that the distribution is also changes its shape because poor people tends to be affected more. So there is a kind of a complex dynamics here. And what we're doing is we're using what governments are using quite a lot, which is everybody is using these poverty lines. So in the Philippines, they have a poverty line and they have a subsistence line. So in theory, you cannot survive below the subsistence line. And in fact, there are like hundreds of thousands of people who are living below the subsistence line. So it's basically people really, really in extreme deprivation. And we communicate our results with the number of people falling in poverty. And the value of doing that is, you've seen the complexity of what I discussed. If you want to go through that with your average minister, it will be a very complicated session. If you tell somebody, if there is a hurricane in your region, there are like 200,000 people falling in poverty, everybody understands that. So we're trying to summarize all of this complexity into indicators that really everybody understands and are really, really basic. We were also trying to do something else with this because we're not very happy with those head counts, because counting the number of people falling in poverty, it's nice, but first, if you have a lot of people in poverty already, they cannot fall in poverty anymore. So what happens to them doesn't matter for your metric, which is sort of a problem. And therefore, we have been also trying to calculate these well-being losses. And I won't go very much into the details here, but the idea is that we cannot assess well-being, but maybe we can assess well-being losses when there is a disaster. It's probably a simpler thing to do. And what we want to capture here really is this idea that if I have to replace my roof and pay like $3,000 to replace my roof, I will be able to cut on luxury consumption that I have, like vacations and stuff. If you go to the left of the distribution, income distribution, people will have to cut on food, education, and healthcare. And we have very good evidence that first cutting on food, healthcare, and education means more well-being losses than cutting on luxury consumption. But also that when you start to cut on those three things, especially for children, you're not talking about temporary impacts anymore. You're talking about permanent impact, in the sense that in Mexico, for instance, when a kid is taken out of school because of a shock, 30% of the time the kid will never go back to school. So you have a shock, but the shock is there is no reconstruction, right? The family, I mean, the path of that child will be different forever, because the child will never complete primary or secondary school and have a very different life. So we know that we need to represent that if we want to be fair. We don't know really how to represent that because it's again extremely complicated. So we do it very simply by just having a scaling factor. So when somebody loses $1 in consumption, this dollar will be worth $0.1 for Bill Gates, because the guy will never notice, and $10,000 when it's like a poor farmer in Ethiopia, because $1 means a lot for that person. And we calibrate how we transform consumption losses into well-being losses with like an elasticity that represents how much worse it is to lose consumption if you're already a poor person. So, and that's really how we calculate these well-being losses. And then because we had asset losses in that path, we can take the ratio of that and assess this resilience, which is the ability for, like, say, a household to lose like 5 goats and a roof and still maintain well-being. So to conclude, I just want to show you what it looks like when we apply that to the Philippines. And it's a paper with Brian Walsh that we did in close collaboration with the government there. I just want to go to the results, where we have first in that chain of calculation, we calculate the risk to assets. So this is the economic losses as everybody is using. And if you map it, you find, of course, that's mostly in Manila. And that's because that's where rich people are. So if you use asset risk to target interventions, you would be investing in Manila to reduce those risks. If you look at poverty, you see a very different map. Manila is not really so important, but you have more like the eastern shore of the Philippines and the south part of this big island in North Luzon. So if you do disaster risk management because you care about poverty, you will invest in a very different place. And so the first one, you see mostly rich people. The second one, you see mostly poor people. If you want to take into account everybody and in a way that's kind of fair, well, this is this well-being loss that we're trying to propose to guide decisions. And it's basically this idea that you want to look at asset losses because it still matters how much pesos you're losing, but you also want to take into account that the same peso means different things for rich and poor people. And the second map is trying to make that balance and to propose a way to prioritize action. So this is what we did with the government of the Philippines, try to help them decide where to spend their money on disaster risk management. And I want to show the last map, which is socioeconomic resilience. And it's really interesting because this last map looks completely different from the others. The south of the country, Mindanao, is the least resilient part, but it doesn't really show up on the risk maps. And that's because the south of the country is very, very poor, but not affected by typhoons so much. So basically, this south of the country is not hit very often by disasters, but when they are, they suffer quite a lot. And so, here my point is that really to know what metric we want to use, you really have to work with governments and tell them, what do you care about? Do you care about economic costs? And this is the first map. Do you care about poverty? This is the second map. Or do you care about the vulnerability of your population and you want them to be able to cope with shocks, even if they are not that frequent? And in that case, it's the last map. And very often you have experts using metrics that they kind of like decide are the good metrics. And what we're trying to do very much in all of our work is to engage with the policymakers and the decision makers to ask them, what is your policy goal? If you give me your policy goal, I can transform it into a map of where you should invest. So it's really like transforming the kind of like vague and ill-defined priorities that decision makers have in their mind, and to transform that into some of quantified way of deciding where to invest. There are many other things that we're doing in the Philippines, like looking at impacts for poor and rich people and so on. I mean, as expected, rich people are losing more assets, but losing much less well-being than poor people. So it means that redistribution, taking money from rich people and giving it to poor people after a disaster, is a good thing after a disaster, which is something that we keep repeating, even though policymakers don't always are not always very receptive. And finally, and this will really be my last slide, we can also look not only at poor and non-poor people, but look at other characteristics. So here in Sri Lanka, we're comparing the ethnic majority and the ethnic minority. You know, the country has been in a civil war for a long time, and there are still big tensions. So we think that this tool can also be useful to look not only at this poverty angle I started from, but also at other forms of inequalities, including things linked to religion or ethnic backgrounds. So I'll stop here. And I mean, as you see, this is a massive work program that touches on health and food security and pure economics and engineering and so on. So this is really a topic where if you see any way of collaborating or exchanging, we would be very happy to do so. So thanks a lot, and looking forward to the discussion.